All right, let's pull back the curtain on one of the internet's oldest organizing principles, IPv4 address classes. You can think of them as the internet's original neighborhoods, each one with its own very distinct character. So let's dive right in.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
I mean, have you ever really stopped to think about it? You've got billions, literally billions of devices online. Your phone, your laptop, servers all over the world. How in the world do they find each other? It seems like magic, but the answer begins with the humble IP address.
So, let's break down what an IP address actually is, because it's not just some random string of numbers, not at all. Every single address tells a story, and that story is split into two really important parts that give it all its meaning. And you know what? The concept behind it is actually super simple. You've got the network ID. Think of that as the street you live on. And then you've got the host ID, and that's your specific house number. Put them together and bam, you have a unique address that can be found anywhere in the world.
Okay, let's make this concrete. Look at this address, 9, 100, 100, 100. In this specific setup, that first number, the 9, is the network ID. That's our street. And the rest of it, the 100, 100, 100, well, that's the host ID, the house number. This split, this distinction, it's everything. So that brings up a really good question, right? If every address is split into a network part and a host part, who decides where that split happens? Well, that's exactly where the original class system comes into play. See, the pioneers of the internet knew that not all networks are created equal. A tiny business has totally different needs than, say, a huge global corporation.
And this right here just lays it all out perfectly. For a Class A address, only that first chunk of numbers is for the network, leaving the other 3 for all the devices. Class B, that's a nice even split, 2 and 2. But then look at Class C. It uses the first 3 parts for the network, leaving just that tiny last part for the actual hosts.
So let's talk about Class A for a second. These were the absolute giants. We're talking about a very, very small number of massive, global-scale networks. Think about the earliest internet pioneers, or gigantic multinational corporations. That's who these were for. And when I say massive, I am not kidding. Check out this number. A single Class A network could support over 16 million individual devices. That is one single street with almost 17 million houses on it. It's mind-bogglingly huge.
Okay, so we've seen the giant. Now let's jump to the complete opposite end of the spectrum to really see the contrast. Forget about the global corporations for a minute. Let's talk about Class C. These were built for, well, for everyone else, for countless small local networks.
And just look at that difference. A Class C network can have a maximum of 256 addresses. So we've gone from over 16 million all the way down to 256. It's a totally different universe, right? Built for a completely different job.
Yeah, this really hits the nail on the head. Each address class represents a network of vastly different size. It wasn't just some arbitrary label. The class you were assigned literally defined the size and the potential of your network right from the get-go.
Okay, this is all great, but how can you tell what class an IP address is just by looking at it? Well, there's a trick, a secret code, if you will, and it's hidden in plain sight right in that very first number.
So yeah, how do you do it? How can you just glance at some random IP address and go, that's a Class B? Believe me, the answer is way simpler than you'd think.
And boom, here's the cheat sheet. It all comes down to the value of that first number, that first octet. If that number is anywhere from 0 to 127, you're looking at a Class A address. Simple. If it's between 128 and 191, you got it, that's a Class B. And if you see a number from 192 up to 223, it's a Class C. Now, technically, this is all determined by the first few bits in binary, but honestly, all you need to remember is these simple number ranges. It's really that easy.
But wait a minute. If you're paying close attention, you might have noticed that Class C only goes up to 223. What about the rest of the numbers up to 255? Well, that's where we get into the other classes, D and E, and these guys are reserved for some pretty special jobs. So Class D, which covers the range from 224 to 239, is used for something called multicasting. Think of it like sending a single piece of data to a specific group of computers all at the same time instead of just one-to-one. And Class E, that's the top range, and it's basically off-limits, reserved for experimental and testing purposes. So you're probably not going to bump into those in your day-to-day life.
Okay, so that's the whole classic system in a nutshell. But, and this is a big but, here comes the plot twist. We don't really use this rigid class system anymore. So you might be thinking, why did we just go through all that? Because you absolutely have to understand this history to get how the modern internet actually works.
These days, we use a much more flexible system called CIDR. That stands for Classless Interdomain Routing. It basically throws out those rigid A, B, and C blocks and lets us be way more efficient. But the key thing is, CIDR was invented to solve the problems that this original class system created. It's the next chapter in the story.
And that is why this still matters so much. You really can't get a deep understanding of modern networking without knowing what it was built on top of. Learning about these old address classes? It's a fundamental piece of the puzzle. It's kind of like learning how to count before you learn how to do complex math.
At the end of the day, the internet is built on all these layers of history, and the old class system is just one of those layers. Makes you wonder, right? What other old, foundational, maybe even what we'd call obsolete, rules are still humming along in the background, quietly running our digital world today?